assessment reminds us that the keto form is often more stable than the enol form. However, in this case, the enol form is actually more stable. Why is that? There are really two reasons we can use to rationalize why the enol form is more stable. First, the hydrogen between the two carbonyls in this particular example is more acidic than we would expect a typical alpha hydrogen to be. By being flanked by two electron withdrawing carbonyl groups, that makes that hydrogen more acidic. That makes this molecule less stable and higher in energy overall. Furthermore, the hydrogen on the oxygen in the product can be stabilized by hydrogen bonding with the neighboring carbonyl oxygen. By stabilizing this molecule through hydrogen bonding, that makes the product side more stable and lower energy than we would otherwise expect. The starting material is higher in energy, the product is lower in energy. That makes this particular enol more stable than we would otherwise expect.